Right, in this video, we're going to learn how to complete the square for quadratic functions y equals to ax squared plus bx plus c, where the values of a, right, it's either 1 or -1. Right, but before we do that, before we go into the details, let's try to understand what does completing the square mean. All right, so to understand what completing the square means, we're going to do it pictorially. So let's start off by having a figure comprises of a red square and two orange squares. So you realize that when you put these three figures together, you do not get a complete square, right? So the questions you have to ask yourself is that what must you do to make it a square? Because currently the image you see on the screen does not make it a square yet. Alright, so what must you do? So yes, you need to add this blue square, and by adding this blue square, you can see that we can actually get a complete big square on the screen. So this is exactly what we need to do. Given any quadratic functions, okay, what we need to do is we need to add this blue square to these quadratic functions. So what does it mean by adding this blue square to the quadratic functions? Right, let's do one question. Let's try to complete the square for x squared plus 4x. So what we're going to do is that we're going to represent x squared and 4x pictorially. So let's start off by representing x squared. Let's start off by having a red square where the length is x units and the breadth is x units. So x times x will give you x squared. So that's settled for the x squared. So how about 4x? 4x we can start off having a rectangle where the length is x units and the breadth is 4 units. So 4 times x will give you 4x, right? So the next thing is that we're going to split this blue rectangle into two smaller blue rectangle, right? Where the length is x units, but the breadth now become 2 units each. So we see that 2x plus 2x will give you 4x. So the next thing we're going to do is we're going to combine these three figures that put the tick, and let's see what happens. Right, so we can see that it is not a square yet. Okay, what is missing is this part here. This is the one that's missing. So what do we need to do to fill up the part? Yes, we need to add the yellow square. So this yellow square will have length 2 units and breadth 2 units. And if you were to add up the areas of all these figures, the red square and the two blue rectangle and the yellow square, let's add it up. You'll see that you get x squared plus 2x plus 2x plus 4. And you can simplify it into x squared plus 4x plus 4. So x squared plus 4x plus 4, this one here, would remind you of your a squared plus 2ab plus b squared, the algebraic identity where you can collapse it into bracket a plus b squared, which what we have here, bracket x plus 2 squared, and this is a perfect square. Right, let's do another example. Let's try to complete the square for x squared plus 16x. So similarly as what we've done earlier on, we're going to represent x squared and 16x pictorially. So let's start off by having a red square where the length is x units and the breadth is x units as well. So x times x give you x squared. So likewise for 16x, we can represent it by a rectangle where the length is x units and the breadth is 16 units. And from there we can split it into two smaller rectangles. Alright, then the next step is as what we have done earlier on, we're going to combine the three figures. We have put the tick there and see what we get. Right, so it is not the square yet. So we have to add the yellow square as indicated in the diagram. Right. So as what we have done earlier on, we're going to add the areas of all this figure, the area of this red one, this two blue one, and the yellow one. You end up getting x squared plus 8x plus 8x plus 64, and that can be simplified into x squared plus 16x plus 64. This one here will remind you again of your algebraic identities, which will collapse into bracket x plus 8 close bracket square, which is a perfect square. So this is a perfect square. All right, so we have done two examples. You can continue to do it for x squared plus 16x or x squared plus 22x or x squared plus 50x, so on and so forth. Right, and then let's try to analyze the results. So to complete the square for x squared plus 4x, we need to add the number 4. To complete the square for x squared plus 8x, we need to add 16. Right, to complete the square for x squared plus 16x, we need to add 64. All right, so on and so forth, etc. and etc. So the question is that, can you see a pattern? How do you manage to get this number 4 here? Or this number 16 here? Or this 64 here? Right, so if you observe it carefully, to get 4, you actually go to the x term, take the number in front of the x term, divide it by 2, and you square it. Right, so if you're going to represent this 4x, 8x, 16x, 10x, 20x by a value, okay, if you're going to complete the square for a squared plus 2ba, that means to complete the square, we need to take the coefficients. In this example here, in the first few examples, we are taking the coefficients of x. 4 is the coefficients of x. 8 is the coefficients of x here. 16 is the coefficients of x here, so on and so forth. So if you have a term 8x, ax, that means a is the coefficients of x. Right, so you take the coefficients of x and you divide by 2, you square it. So instead of having x squared plus bx, okay, so alright, so if you have x squared plus bx, okay, to complete the square, then we need to add b over 2 squared. So if you have x squared plus cx, then we need to add c over 2 squared to complete it. So let's say if you want to complete the square for a squared plus 2ba, so now your a is equivalent to your x, right? So the coefficients here will be 2b. That means the coefficients of a here will be 2b. So you divide by 2, you square it. So we need to add b squared. All right, similarly, if you have x squared plus 2bx, all right, so we need to take the coefficients of x, which is 2b divided by 2, square it at b squared. Right, so this is how you the steps that you can apply to complete the square for quadratic functions. Okay, so we're going to extend the knowledge to completing the square for x squared minus bx. Just now what we have done is only for x squared plus bx. So if x squared minus bx, what do? We still do the same. We concentrate on the coefficients of x. In this case here, of course, the coefficients of x is no longer positive 4, it's negative 4. So we add the bracket negative 4 over 2 squared. And for x squared minus 8x, okay, we add bracket negative 8 over 2 close bracket square. Right, so if you have x squared minus bx, right, so to complete it, what is it we need to add? We need to add negative b over 2 close bracket square. Alright, so in summary, if you have x squared plus bx, to complete the square, we need to add b over 2 squared. And if you have x squared minus bx, to complete the square, we need to add bracket negative b over 2 squared. Alright, let's try to do this x squared plus 6x. So do you recall the steps? Yes, the first step is to zoom into your x term, which is 6x here, and then further zoom into the coefficients of x. So the coefficients of x is a positive 6. Right, so to complete the square, we will need to add 6 divided by 2 squared. Alright, now the thing to consider here very carefully is you're actually given 2 terms here only. If you look at the questions, you're only given 2 terms. So if you're just going to add an extra term here, then you're making it 3 terms. Right, so 2 terms obviously is not equal to 3 terms, right? Right, then you're actually changing the questions, which does not make sense. So what we need to do is we have to take it away, so that this one, something minus something, this one will end up give you 0. So you end up just having 2 terms, which is the original questions. Okay, so let's erase all this. Right, so this is what we need to do. And this one here, right, this one here will remind you of, your that red rectangle, the 2 blue and this yellow one. This one will collapse it into a perfect square, which will be x plus 3. So how do you get x? How do you get plus 3? 6 divided by 2 is a positive 3. So that's how you get x plus 3. Then square this one. Use the calculator or mentally, you will get 9. So this is how you do it. Right, let's do another question. Okay, so as usual, let's zoom into your x term. So the coefficients of your x term now is negative 6. Negative 6. Right. So what we need to do is we need to add bracket negative 6 divided by 2, then square it. And then you need to take it away. Okay, because you can't change the questions. So this will be the red square. Remember that will represent your red square and the 2 blue square and the yellow square. So this will collapse into x minus 3. How do I get negative 3? Okay, from here, negative 6 divided by 2 will give you negative 3. So that's how you get bracket x minus 3 and then square. And this here will give you 9. Okay, so what happened if you're given negative x squared minus 15x? Can you still use what you have done previously? So previously, you would observe that what we have been doing so far are just x squared plus something or x squared minus something. Meaning what we are dealing with is we are dealing with the coefficients of x squared to be 1. Right. So if you look at this question here, the coefficients given, it's not 1. It's actually negative 1. Right. So if you're given these questions, then it involve more steps. Right. We will need to factorize your negative 1 out. Okay. So this, right, this will be similar to what we have done just now. Right. The earlier few examples we have done. So we will need to complete the square for this guy here. Right. So let's have a big square bracket. Okay, you need to add something, right? What is it that you need to add? Zoom into your x term. Take the coefficients of your x term, which is positive 15, divide it by 2, square it, add, then take away, close it up with a square bracket. So this guy will become x plus 15 divided by 2 squared. So you can just use your calculator to work this out. I'll give you 225/4. Right, we're not done yet. You still have to multiply the negative into your brackets. This and this will give you positive. Okay, this is how you do if you're given negative x squared instead of positive x squared.